All right, hi everyone. Welcome to today's working group meeting. We can get started. In terms of project updates, uh, there isn't any project updates that we would like to share today. Um, Neither both from at least not from our side, from the upstream community nor the AWS provider. Anything to share from any other providers? If not, we can move on. Um,
I can share that we're trying to get the cluster API provider updated to the latest version of Karpenter, but I'm running into some challenges because I'm curious, like, is there a document that describes like the contract, I guess, that that the provider needs to satisfy in order to make things work? Because like for example, it's the provider's responsibility to mark the node class as ready so that the node pools can become ready then by Carpenter. Like, are there any other I guess, like, is there a list of contractual obligations that like a provider needs to satisfy in order to make the core library happy?
There isn't a document, but we definitely should have one. I think, yeah, with the V1 migration, we did introduce a few different concepts around node class readiness. So we definitely should have one. It's something we can take a note of. But yeah, as far like from the top of my head, it's really just satisfying the cloud provider feels, which is consistent between the V1 beta 1 and V1, as well as the node pool readiness um, configuration, as well as some of the the yeah, some of the launch requirements of hydrating back information on the
Right, right. Like
right.
like the capacity annotation and the instance type annotation and whatnot. Like, because I'm doing a lot of like when I write the cluster API provider, I do it usually in using like mock providers like Quack or I have a KubeMark, provider for cluster API that I use. So like getting the proper information onto the node is sometimes difficult because it's not like a real node, and I don't have a cloud provider there and like a cloud controller manager or anything. So what I'm trying to figure out is like, okay, how do I make sure, because and the difficulty is cluster API is like one provider that actually works on top of many different platforms. And so I've talked to users probably from 5 or 6 different platforms that have tried Carpenter like on their platforms. And these are platforms without a native Carpenter implementation. So the users are interested in doing it there. But what I'm trying to understand is now, okay, what do all these providers need to do to satisfy the contract that Carpenter wants to see in order to like not throw errors and whatnot? So yeah, like I don't know. I mean, I would be happy to contribute to a document like that. I don't necessarily feel knowledgeable enough to start a document like that.
No, I definitely agree. This is a pretty big gap for us, like for onboarding cloud providers, and one that we definitely need to have.
Yeah, I think there's the pretty long-standing issue of like documentation for how to go about writing a cloud provider. And up till now, the unsatisfying answer has been kind of read the prior art with like the AWS provider and such, which I agree that's not really sufficient. Um, for the most part, the cloud provider interface does have most of the documentation, but the gaps you've called out with like status conditions and also some of the global variables you need to populate, like well-known labels. Yeah, it's stuff we know from experience developing it, but definitely something worth writing down in a document.
Yeah, I totally agree, Jason. And I think part of the difficulty for me is like I'm using the the AWS and the Azure providers as examples. So like I am doing a lot of research into those code bases, but a big difference between Cluster API and the platform specific versions is that because in Cluster API I'm just interacting with other Kubernetes objects, like my interface is so much lighter than a lot of what's done in AWS or Azure, because AWS and Azure providers, they have deep interactions with the actual infrastructure, and there's a lot of infrastructure specific logic that's going on there. So for me, it's like I look at the cloud provider interfaces in other providers, and then I try to start digging into I think they're sometimes called providers internally, that
Mhm.
like node claim provider, or those kind of things. And so that's where it starts to become confusing for me because there's just a lot of code to look through to understand all this stuff.
Yeah, absolutely.
All right, well, I'll try to make some notes on things I'm running into, and maybe I can just start an issue or something on the core Karpenter repo, and we can just start to collaborate there, maybe.
Yeah, no, if you wanted to do that, that would be fantastic. I don't know if maybe a Google Doc could also make sense. Um, Something we could link to in an issue and people could collaboratively add as they run into stuff. And I'll definitely try and keep this top of mind myself. And as I run into things where it's like, oh, this is something that isn't very clear that a provider needs to fulfill to meet the library, add it to a doc or an issue.
Yeah, absolutely. I think maybe I'll try to start this issue like in the next few days, and maybe what I'll do is like because of our permissions at Red Hat around how we use Google Docs, I can't just create a Google Doc with public interface, but I tend to use HackMD for this stuff. So maybe what I'll do is just set up a HackMD doc where we could start like collaborating on those things, and I'll just link it in the issue then, and we can have the discussion there if that makes sense to everybody.
Yeah, I think that sounds great to me.
Cool. Thank you. Appreciate the feedback.
Cool. Any other project updates, topics to discuss? If not, then we can just quickly move on over to RFCs. Okay, sounds good. First RFC that we have on the table is the node overlay RFC. This has been something that we've been doing, planning on at least doing for the better part over a year. Basic idea here, basic problem that we're trying to solve with node overlay is allowing users to be able to add different configuration changes to how Karpenter will view nodes. So in particular around pricing and capacity, custom capacity. So like custom resources such as like huge pages, you know, extended resources, around GPUs and such are things that we would like to provide customers an option to be able to add. Currently, how we're thinking about this is just adding a new custom resource definition into Carpenter, and this will be using the same selector mechanism that we do with node pools. It will allow customers to select specific instance types and then do an adjustment on the capacity or the price. Uh, and then that way, Carpenter is able to keep this in mind while it's doing its scheduling simulations, and be able to properly and adequately account for the different prices and capacity that we're going to need to think about. So that's just kind of like a high level overview. This has been heavily requested for some time now. So if people can take a look when you have the chance, if you have any questions, feel free to raise them.
Is there any time you want to target getting this merged by?
Yes, I would like to target getting this merged by 2 weeks from tomorrow. So like on the 6th of June.
All right, sounds good.
Yeah, so any feedback. Does anybody have any questions around this? Okay, cool. Yeah, this is the second RFC that we have opened around this. This actually takes a little bit, it takes inspiration from the first RFC and just actually defines a little bit more concretely what we're going to implement for this alpha feature. Yeah, Michael?
Yeah, I'm just gonna say, like, if you're gonna put a lazy consensus on it to merge it in like 2 weeks or whatever, it might be worth just adding a note, adding a comment here so the people who aren't at the meeting, who are following the issue know or whatever.
Yeah, we'll do. That's a great call out. Cool. Okay, we can move on to the second RFC.
Yeah, so this is kind of like a revisitation of an issue that I brought up last year. And the user story here basically is like, as a Karpenter, user, as a Karpenter, admin or whatever, I would like to provide Karpenter as a service to my users, but I don't necessarily want to expose the node classes and the node pools and whatnot to them. So I want to create like an API, like a mirrored API that they could access, and then I could gate those changes into the full like node classes and whatnot. And in some ways, I view this as similar, like my experiences using EKS. When I get like an EKS cluster with Karpenter enabled, and I'm like admin in the EKS cluster, I can't necessarily see like the EC2 node classes and whatnot. And part of this, is like we want to create a service, or we want to create an experience so that users could deploy Karpenter in a way where, like the end user of the cluster that Karpenter is managing is not then able to do something like change the AMI in the EC2 class or something like that, right? And I know there are ways that, there are other ways to do this, like, we could use validating admission policies and whatnot in the workload cluster, but if we're going to give the workload cluster user like an admin privilege, they could still do things like try to disable the validating admission policy or try to sneak something in, even if we have external controllers that are like reconciling changes back into the cluster. So what this issue is about then is like, okay, is there a way that we could allow Karpenter to have like an extra kube config where you could say, when I give it this extra kube config, I want it to use that kube config for writing to its node classes and node claims and node pools. So we could essentially separate how it looks at nodes and pods and all the objects related to scheduling in one kube config. And then if needed be, we could use another kube config to look at the control objects. And this can be done in a way where it's completely backward compatible, where like it doesn't affect or disrupt users who aren't using this feature. But I would think for other users who are attempting to deploy Karpenter in this kind of managed service mode, that this is a concern for the owners of the managed services, basically. Like that, there's a risk in handing out admin credentials in a way where the user could then break their own cluster, that's like outside the managed service, like service level agreement or something like that. So my colleague Alberto created this issue. And yeah, like I just wanted to talk about it and see like, is this something that like the Karpenter community would be interested in investigating? Like if we like Red Hat do some investigative work here and put some PRs up around this, is this something that the community would be interested in entertaining or looking into? Or, maybe some of the EKS or AKS folks have advice about this kind of stuff. Like, yeah, I'm here for all of it, basically.
So kind of just trying to wrap my head around this. You the idea being like you don't necessarily want to expose the configuration surface of Carpenter to these users, right? You wouldn't necessarily care. You wouldn't care about exposing the node claims specifically, right?
That's a good question. I don't think so. Like, I don't think the node claim is really that deleterious, because like the worst that a user could do is like delete the node claim, and that would just make the node go away. I think the bigger issue is around like node classes, right? Where if I'm the operator of a service and you're my, user, and you said, okay, operator, like I want to have a cluster that has like, this kind of automatic Carpenter scaling, turned on, right? And then I give you an admin credential, and your ops people or whatever are like trying to figure things out, and they like, they mess up the node class in a way that now the cluster is broken, right? And this is going to require some sort of call back to the managed service operator, me, to come in and try and fix it for them, right? So as the owner or the operator of the service, what I would prefer to do is give my users some sort of like copy of the node class where they can modify that, and then it gets reconciled into a different namespace or even a different API server. And I would have the chance to do some validation on that before it actually got applied to Karpenter. So really, this is about like, I want to try and create a service where I can minimize the potential for users to disrupt their own cluster or to break it in a way that might take the service down or something. Does that make sense?
Yeah, that makes sense because we've seen this kind of general problem before as well. It's not yeah, I wouldn't say it would be unique to you, to y'all. Where we, like you said, with EKS, you provide them a particular node pool node class, and eventually that will get re-reconciled once if the end user is messing around with it. Yeah.
Right. And I think like, you know, we're doing something similar right now. We're kind of experimenting with you know, like kind of almost what Jeremy is talking about what they do at Salesforce there, where they, you know, we have an external controller that's able to reconcile changes on like node pools and node classes and whatnot, you know, back into the workload cluster, right? And we're using like validating admission policies to prevent the user from being able to, you know, access the node classes that are in the cluster that they're in. But it's still possible that a user with sufficiently high privileges could disable the admission policy, right? And then they could make changes before the external controller could reconcile them. I'd be really curious to hear more about Jeremy's use case too, because it sounds very similar to what we're getting into. Yeah, and I'll hand it over to Saurav.
No, I think, I mean, this is fairly interesting. So I really appreciate you bringing it up. I think this seems like it's one of those general class of problems wherein there just isn't enough from Kubernetes to prevent customers from shooting themselves in the foot. And there are like, there is no better separation of responsibilities in the sense that yes, like you might still want to make someone an admin, but do you want them to remove some critical resources or what you consider as critical resources? I think it eventually, like the solution at least that I have seen so far, eventually boils down to having some sort of an external component which keeps an eye on these things and then reconcile it. Now that reconciler could be like a piece of code that's like totally sitting outside the cluster. I think what you are proposing is basically like a controller of sorts, which is in a different admin cluster and which kind of keeps a track of these resources in the guest cluster. Is that correct? Am I understanding it correctly?
Right. That's like the solution that we're kind of like, you know, circling around now. But like what we're looking at from our engineering perspective and what, you know, we kind of like to do is say, okay, you know, what if we could make this in a way where the control objects like node classes, node pools, et cetera, what if they could be put in a different API server altogether? Like what if they weren't commingled with the workload API server? And I think that would create an architecture then that is like completely bulletproof for people who want to hand out Karpenter as a service, but also protect the infrastructure from like, you know, users having a foot gun, basically.
And when you say have them in a different cluster, is it just for storage purposes? Because I mean, you'd still need to apply those CRDs in the actual cluster where you're going to create those custom resources, right?
Well, right. So like the notion here would be right now, if I start Carpenter up, it has one kube config, right? And that
Mhm.
kube config is used to talk to an API server that houses both the nodes and the pods and all the workload kind of classes, but it also hosts the Carpenter classes, right? Like the node pool, node class, node claim. So the idea would be, what if Carpenter could, under some circumstances, take two kube configs? And one of the kube configs is used to point to whatever, you know, what an API, a different API server, a different scoping on the cluster, what, you know, whatever the user needs. That kube config is used only for the node pools, node classes, et cetera. And then the main kube config or whatever is used for the workload cluster to monitor its workloads and everything. And then in that respect, when you have that separation, now the owner of Carpenter can give out the kube config for the control objects to whoever they want to, right? So if there's a trusted user in the workload, maybe I would give it to them. Or maybe I would have objects in the workload cluster that an external controller can then replicate into the API server that actually contains the concrete objects, right? So building, it's not just building separation on the workload cluster where all these things are currently commingled. It's building a hard separation that would make it extremely difficult for a user to get to those other ones or get to the control objects.
I see. I mean, I still have other questions, but I see there are other people in the queue, so I'll let them go first. But I think my 2 cents would be that there are a lot of questions here. Um, I don't know if we want to do like a full RFC, but maybe at least like having a more verbose description of how this would look like and how that separation that you talked about, I think it would just make everyone make it easy for everyone else to be on the same page.
Yeah, absolutely. Happy to put more user stories in there and kind of sketch out what this would look like and everything.
Yeah. Thank you.
Yeah, Reed, I think you're.
Yeah, I just had a question. So I think this is a problem that is not specific to Karpenter, right? It could be a problem that is faced by any controller or add-on or whatever people are running when you have users that have some sort of elevated kube config. Even if we're vending out something, there's potential for them to just take cluster admin and then begin wreaking havoc in their cluster. And so with that, I'm not totally sure, and I would love to see the RFC doing like these kind of trade-offs in this analysis is it something that is handled by Carpenter, the application, or is it something that is larger within Kubernetes that needs to be upstreamed where there is there are better controls for admission in the first place? And so I linked it in chat here as well. I know that there's CEDAR policies that are being worked on, and Micah is I think he's SIG chair for security now, if I remember correctly. And so I think maybe pursuing something like this and getting this upstreamed as soon as possible generally solves this problem for us, if I understand correctly.
Does it though? Like I guess that's my question, because so I think there's like, I guess I put this in the chat. I think there's like two classes of issues here as I perceive them. Like there's I can't exclude things, which I think is the cedar issue. And then there's I don't want people to escalate from their role, which I maybe can also be solved with cedar. I'm not sure, because it's basically like yeah, it's effectively a permission boundary in AWS. Like I want somebody to both have access to mutate their roles, but not exceed the permissions under which they, like, not create a role that then has more permission than they currently have. And I know that Mike has thought about this problem of like escalation through like role creation, because IAM also has this issue. Because if you don't solve it that way, then you have to solve it outside the cluster, where you have like a policy that's defined like through an IAM permission. I'm talking about EKS specifically, obviously, but like you have a policy that's defined through an IAM permission, like an access entry, and then that sits outside of the bounds of what somebody could touch.
Would that
Right.
still be something that becomes a concern of each controller that is being used in a cluster, or is it still something that is a larger Kubernetes issue? And if Cedar's not the total fix, I guess that's what I'm trying to understand.
It's two issues. Jonathan's rightly identified. It's two issues, right?
Yeah.
And I need to read more about Cedar, but yeah, one issue is like having very, very well scoped permissions inside a cluster that everyone's operating on, right? But
Right.
another issue is, and this is kind of like the same thing with like a Linux or Unix system, right? Like, how do I hand out a root privilege credential to someone and also protect part of the system, right? And in Kubernetes, like one of the traditional patterns for this is like, okay, well, if I need to protect certain parts of this system, what I should do is write a controller that looks at a different API server so that I can control the other API server and never, that way I can hand out root access, or I can hand out cluster admin access to the cluster that a user is using. And I can be assured that they'll never be able to modify the configuration for that controller. Now they might be able to have that controller, they could modify the in cluster configuration for that controller. But if I can then move that controller out of the cluster they're operating, then like it appears they can't get to it. And this is like kind of my question, and maybe for the AWS folks, if any of you look at EKS deeply, and I noticed Reed, you put EKS next to your name there. So like I've been doing some testing with EKS, and when I get an autopilot cluster and I look at I look inside the cluster and I try to look for like the Karpenter specific objects. Like theoretically, I'm an admin on that cluster, but I can't see some of them, right? So the question is, okay, why are those being hidden away from me? Presumably so I don't foot gun myself, right? So how do I replicate that in a service that I'm creating, right? Like what, and if that's just being done with like admission policies and maybe the user doesn't really have admin on that, okay, like that makes total sense to me. Like what Jeremy's talking about here, they don't allow tenants to have access to the cluster scoped objects. But in our specific case, we don't have that option because when we create a guest cluster for someone, we want to give them admin permission in a way that they understand they have root control of the system. So what we'd like to do is pull Karpenter out of that cluster, and we're already running Karpenter somewhere else, so they can't modify the Karpenter deployment. But we still have to have like the node classes in the cluster. And no matter how many like guardrails we put around them, there's always the possibility that like a savvy or user could create some automation to like, undo what we've done, right? Like it could race the Kubernetes API server or whatever. So like we have engineers who are like ready to start looking at this problem and would be happy to propose like, RFCs or like PRs, whatever it would take. Like I think this could be done in a way that is completely backward compatible and is just an option if people want to turn on like an extra, switch basically to have this extra kube config. Does that kind of answer what you were asking, Reed?
Yeah, I think so. Definitely something to kind of think about more.
I think you kind of recognize, like Omiko, that the solution that you're describing is like a slapped on solution to a more core problem in Kubernetes, which is like admission is not perfect and like it needs to improve.
Right. Totally.
And like that's probably a long road. So like at the same time, I'm not sure like what the timelines are in that, but I think it's worth
Right.
exploring. Like
Right.
what are the like what's the roadmap for this kind of like permission boundary? I'm framed in kind of IAM world, so permission boundary-esque, more verbose role assignment thing, which I don't fully have context on, but I know is kind of being worked on. So I'm just curious where that's at on the roadmap in Kubernetes, because I think that would help define like
Yeah.
what we decide to do ourselves. But
I mean,
yeah,
yeah, this is good input, and I'll definitely try to do some research around that. I guess part of my concern here is like, uh, this is a problem. Like another way to solve this would be like I say we like Red Hat, we could make an addition to like the Go client or controller runtime that would allow some sort of finer grain, some finer granularity or whatever. It doesn't have to be a Carpenter thing, but like I think as opposed to like boiling the ocean and trying to solve this for all of Kubernetes, a very easy change would just be to allow Carpenter to take an extra kube config, right? And so like solving the problem here might give us more traction than like waiting for the upstream to kind of solve some of these more, difficult problems, I guess. And that's kind of what we're trying to evaluate, basically.
have you seen this, the multi-cluster runtime project?
I have been following it over the years, but this might be a new implementation on it that I haven't seen yet.
Yeah, I know this. I think this is relatively new. Yeah, it's relatively new as far as I can tell from commit history. I haven't looked deeply at it. I don't know if it even enables what you're describing.
Well, the only reason I'm saying over the years is because I see like, the top contributor here is Stefan Szymanski, and he had opened an issue like a year or two ago in I think controller runtime talking about a multi-cluster approach for, baked into controller runtime. So I'm wondering if this is like some of that work has been spawned off into a separate project now. So like because it
Yeah.
sounds similar to what that was too.
No.
But yeah, this is more research for me. I appreciate you sharing this. So anyways, like if the community is okay with it here, like I'll certainly add more details to that issue and try to describe more of the user story we're getting at and kind of the architecture that we'd want to see. And then, maybe we can talk about it again in a future meeting if people are cool with it.
Okay. Let's move on to community questions. MW.
What's up?
Oh, it's the community questions. We just had a community question, starting the community question. I guess, does anybody want to talk about the first question?
Oh yeah, I think that was added by Min Wang.
Oh, okay.
Hey, hello. Is this time for us to talk about this?
Yes.
Okay. Yeah. Hey, me and Jeremy both from Salesforce. We're actually on the same team. Yeah. So I have some questions about the memory overhead. Yeah, you can open that one. So I can give some context. So what we see in the real case is, we have some kind of a customer's pod. So they have one pod per node. So it can have some kind of a case is the pod cannot be scheduled on the node. So after we reading the documentation in the Karpenter, right, there is a one parameter, I think it's called VM memory overhead percentage, right? So right now the default value is 7.5%. So we are thinking, we probably need to adjust this value a little bit to make sure, have one pod whose memory is very close to the node memory, it can be scheduled. So when I just doing the research, I just, found the link I shared. So I have one questions. When we reading the documentation there, I feel like they give us two kind of values in documentation I share. So one should be the total, memory in the node. The other should be the allocatable. So okay, let me share my screen. I'm just curious, like how does Karpenter calculate these kind of things? So let me share my screen for real quick. Okay. Screen. Entire screen. Let me know if you guys can. A second. Okay. I have some kind of a hold on 1 second. Yeah, probably you can share. I can just talk. I somehow need to do the share of the set of my. Yeah, do you mind to share your screen again? I can just. So you can see. Yeah, so you can see. Yes, stop here. So you can see. So my understanding is when we see this resources table, so you can see the memory like 2, 3, 4, 2. I feel like this is more like the allocatable memory. Is that correct?
Yeah.
And then if you go up a little bit, you can see that, yeah, here. So stop here. So you can see that memory. Yeah. So this memory is more like the total memory. Is that correct?
Mhm.
So when I do the math, right? So I use the allocatable memory and then just divide by this one. So based on the values, I thought it should be around like 92.5 because the 7.5% is for the overhead. And then so you divide you minus that one, that will be the real allocatable. But when I doing this kind of math, the value usually is not a 7 point, it's not the value. So I'm wondering, so how do you guys, calculate this real allocatable memory, and then so in the overhead memory, so how do you decide that 7.5%? So I'm just curious how the math calculated here, so I can do the testing on my side.
Yeah, there's a troubleshooting entry actually that details this math. I'm going to see if I can find it,
Yeah,
either a troubleshooting or an FAQ.
yeah.
But basically, there is more than just the 7.5%. So the
Uh,
values you see in the instance type documentation, that is based on Carpenter's default, both like environment variable settings, so the 7.5%, but also the default EC2 node class settings, which is going to have some default cube and system reserved, which are also taken out of allocatable. So
okay.
I'm going to see if I can find the like concrete formula we use.
Yeah.
It's in the docs. I don't remember exactly where off the top of my head, but uh, yeah, that
Yeah, if
does
you can,
exist.
yeah, you can find that one. You can just paste that in the documentation. I would want to read that one so I can understand this more deeply. The other question is I want to hear you guys experience. So when you in your work, do you have the similar case like you have this one pod try to deploy one node, but it cannot be there because the memory is so close. So when you're doing that, do you just try to make this overhead value bigger, or you try to make it smaller?
Yeah, so I think we've definitely heard of the issue before. There are some mixed ways to go around it. As Jonathan mentioned in the chat, and I did link, by the way, the troubleshooting guide in the chat as well.
Okay.
VM memory overhead percent is a very imperfect solution. Basically, what it's solving for is the hypervisor, and based on the AMI, takes some unknown amount of memory from the node. So allocatable is going to be lower by some percentage point. But that varies. We found that 7.5 is a pretty even value, or it's a pretty safe value to use across the board. It used to be, because this value affects every instance type, lowering that value of 7.5%, while it might bring you closer to the real value for certain instances, it might mean that Karpenter starts overestimating the memory available on other instance types. So this could result in scheduling failures. Today, this is a little bit safer because we have a controller which discovers the real memory once it launches an instance. So if it launches an instance, the expected memory was greater than the real memory, Karpenter caches the real memory and will like launch the next bigger compatible instance.
But what if we, what if we increase this value?
So increasing this value, I think, would be worse for you in this case, right? Because this would mean Karpenter would consistently underestimate the amount of memory available on an instance, and either mean it just can't schedule, or will, like, if you were supposed to fit on a 24 XL and the next option up is a 48 XL, you might get an instance that's nearly 2 times as big.
Yeah, it's more expensive. Yeah. So in that case, what are your guidance? Because we definitely have this kind of issues, you know. So in the today's world, what we did is we're saying, customer, can you just try to reduce your memory settings to fit into this node? So you're doing that, but I think it's not a very good experience because you every time need them to manually adjust that one.
Yeah, I agree. It's not a great experience today. I think this is a design space we want to explore more and try and figure out a better solution here than VM memory overhead percent. I think today the options are doing what you said, lower the memory to be within Karpenter's expectations. You could also experiment with lowering VM memory overhead percent. As I mentioned, this should be safe today. It could result in initial node churn as Karpenter overestimates the available memory on some instances, and it might launch one, realize it's not big enough, then launch the next bigger one. But it should eventually come to a stable state. So you could experiment with that.
Yeah, because my current thinking is our current instance, we're using like a 4XL and larger instance. So you can think about in that kind of case, even like you can say like 5%, you can still give quite a lot of overhead, memory. So we are thinking, we probably just want to reduce from 7.5, probably we'll test like see if 5 is okay, or maybe you can even try go to see if 2 is working properly. But for our testing, we can only just try and then see how the workload performance. But I'm just wondering if there are any better tool, can be smart enough to tell us, this exactly what you need. But I did some research. I don't see there's any product, in the community can do that. So just want to hear some experience from folks. So,
Yeah, I think today the 2 solutions are potentially lowering VM memory overhead percent and experimenting and seeing how much node churn that causes and if that's an acceptable trade-off. And then the other is lowering the memory. Like I said, we recognize that VM memory overhead percent is an imperfect system and would love to see improvement there. I think I know one thing we have discussed, it's not currently scoped into the node overlay design, is potentially allowing per instance type overrides for VM memory overhead percent on node overlay, potentially as a future expansion. But yeah, currently today, I think those prior to are your best options.
So once reduce the pod memory, the other is lower this value, right?
Yeah.
Okay, yeah, got it. Thank you.
If you lower the value though, I would definitely recommend experimenting with it and making sure that it doesn't cause any stability issues.
Yeah.
For a very long time, we did not recommend doing that. We added the memory discovery controller late last year, but I don't know if we've had a lot of customer feedback about how that actually works in practice. So I would definitely make sure you test it out and see that it fits your needs and doesn't cause too much node churn.
Yeah, for sure. Because I think one-way testing probably it's the impact most is for those one pod, one node. Because if you see we have multiple pods in the node, in the worst case, originally you say I want to deploy 10 pods in this node, right? But in reality, because you don't have so much memory, I can say I can deploy 5 nodes. I can use the other 5 pods. I can put the other 5 pods in another node. That works. But for the only one node, right? You have either you're up into the node or you are not there. So I'm thinking just testing this case, make sure the when the pod memory is so close to the node memory, when you adjust this value, see if that can be allocatable on the nodes. That's my thought about the testing. Let me know if you see, any better idea.
Sounds good. Let's move on to the second question.
Yeah, that was me. I just wanted to raise awareness for this. So there's been some conversations happening. Yeah, I didn't make it a link, my bad. Over in Q about Karpenter support, because CAS supports Q directly through a provisioning request API. And I do think, like, as a team and as a community, we should like deeply think about this. I mean, this has been kind of at the back of our heads for a while. I just don't think it's like come up the stack in terms of priority, but it really should, because like AML folks are in mass needing auto scaling. Yeah, so just awareness that this is there. I think it would be nice. It's probably worthwhile. I haven't actually created an issue in our repo, but may also be worth like creating an issue on our side and then just linking out to this. Just an exploratory phase, I think, mainly. Folks are just asking like, hey, this autoscaler supports it. Why doesn't this autoscaler support it? And my response right now is actually the next topic after we're finished with this one. That I think there's another proposal in the community that might help support this. But anyways, yeah, Elmiko, I see you raise your hand.
Yeah, I mean, like I'm also crossing on this issue as well. So I'm happy to move on to your topic if you want to like take up the discussion there, though, if you think that makes more sense.
Yeah, I mean, the next one is basically like there is a SIG Autoscaling proposal for this buffer API, which is now a KEP, or I think it's going to be a KEP. They just raised a PR. Somebody on the cluster autoscaler side raised a PR last night, I think. There was like a Google Doc that we were kind of having a discussion on. I'm still like, there's different points about the API that I may be a little bit not sure about. But I would encourage folks to read this. I do think overall, like the motivating examples are fairly relevant for us. It's basically the pod overhead headroom concept that we've been talking about for forever. But aligned as like a shared API across autoscaling, and maybe even just across scheduling as well. So that, any component that is like integrating on Kubernetes would basically know about this concept, and we wouldn't have to continually reuse these negative priority pods continually, like having to preempt over and over and over again.
So I'm curious because like I've read a lot of the background docs for Buffer, and I'll just say for the record that I don't like the name of it. I think it's confusing, but I said that on one of the docs. Like, is the notion here though that like Q is going to take up Buffer then, and we're going to somehow deprecate like provisioning requests? Because like this is what I don't understand now is that like they've already created this provisioning request. They've taken it from like beta to GA even. And now it's like we're just going to throw that out and put Buffer in, because Q's now got an integration of Buffer.
The argument is like it's not the same, but I have a hard time believing that, because I'm like reading through this
Right, it's like the same
proposal,
stuff.
and it like seems, I mean, the only difference is like there's this one-shot functionality that I understand to provisioning request where I can like say like try once. And I think there's also like a bit of there's like a gang scheduling mechanism that's kind of roped in there as well, where it's like all or nothing. That isn't necessarily covered here, but my opinion has always kind of been like, I kind of think the gang scheduling semantic on the node level is a little odd. Like I've always thought like, okay, and I think it makes sense, right? Like the gang scheduling mechanism should be applied to the application, and then you should just push that to the nodes based on the application needs. And like putting it on the nodes is kind of a strange concept to me. I can see maybe why you'd want to do it right now because you don't have a gang scheduling concept in the scheduling layer, but like once that exists, I don't see a need for it. And then I think Buffer covers the other piece, which is like I can either fill or continually have this headroom that exists in my cluster. So yeah, I also asked the same question. I was like, okay, so is this like the answer to like, we didn't really like provisioning requests, so like you're going to create this thing that we're going to be more aligned on?
Right.
And I don't, the answer was, oh, they're going to both exist, but I don't know.
Okay. Yeah, because it seems like the core, I totally get what you're saying about the gang scheduling, and I think the separation you're talking about makes sense. But yeah, it's like at the core of this, we're talking about the same thing. Like, I just want to tell whatever is doing the auto scaling or auto provisioning or whatever, this shape of workload is coming. Like, be ready for it. And so, like, yeah, it just seems like these things are serving a lot of the same goals and everything. So, anyways, yeah, like I'm happy to hear there's like forward progress on this. I was kind of curious, like I was curious if there was any deeper story about why we didn't pick up provisioning request for Karpenter, or was it just more waiting for maturity and whatnot?
I think we were waiting for this, honestly. Like I think the back and forth on provisioning request was, we don't think it's like a holistic enough thinking around the problem space, and we'd rather have a more generalized like concept that's more akin to this. Like, and so I'm personally much happier with like the way this proposal is going, because I think it's more akin to what we'd want. Because again, at the end of the day, like it's like I want a pod representation. I think this is effectively what this is. Like it's a pod representation ahead of time that's stored in an API. It's basically negative priority pods without negative priority pods. And I think that's the simplest form of what we
totally
need. Yeah.
All right, cool. Well, yeah, thank you for explaining that in a little deeper detail. Like, I know like there's I know there's lots of people from the Q community who are kind of interested about these interactions, but I will note at the same time that like the main branch of Q right now is like still using V1 beta 1 provisioning request, and that's not even being shipped by the like cluster autoscaler at the moment. So like, like what's the story there, right?
Yeah, I think it's worth a conversation with the Q folks. Like I think we should be more involved there. One thing I'm happier about is I talked with like Kuba like last week, and I know that there's a knowing, like a need in the back of people's heads that like we need to move the time of SIG Autoscaling back, so that we can actually like attend, like us on the West Coast can actually attend.
Totally.
And so they're talking about doing that, which I'm happy about. So I'm hoping that means that like more of us will be able to attend those meetings and be more involved in some of these discussions and just have a better like working cadence generally. But yeah, I'm completely with you. Like how do we kind of bridge the gap there with Q or any of these other like orchestration engines?
Yeah, and just for the sake
conversation.
Yeah, for the sake of information and whatnot, like Emmanuel, if you go back to that the discussion topic about Q and Karpenter, I think this is the one. Scroll up to the top. I think the person who opened this is Kevin. Yeah, so the person who opened this, Kevin Hannon, is one of my colleagues. He and I have been collaborating about this, and he's doing a lot of work on the Q side. So I know there is also other discussion happening in Q about like how to update themselves and like where they're at, because I think they're still catching up as well. So yeah, like I'm happy to have more of these conversations in the future. And I've been trying to keep track of what the Q community has been doing. But yeah, maybe they just like people rushing to kind of get all this stuff done and everything.
Are they in SIG serving? I always forget. Like what's the
Oh, that's a good question. Yeah, I think so.
Or working group serving. I guess it's not a SIG, now that I think about it.
Hosted by SIG apps or something like that.
Yeah, something like that. I'll track that down separately, but yeah.
Hey, cool. We got about 8 more minutes. Any other topics of discussion? If not, we can call it a meeting and end early. Okay.
Thanks, everybody.
Thanks.
Thanks.
Thank you. Thank you.